In this video, I'm going to give you an introduction to the world of testing for Flutter. Through examples that you can follow yourself if you want, we will learn the following concepts. First, we will learn why testing exists and what benefits it brings. We will see what a unit test is and how to create it. We will learn testing techniques such as mocking or stubbing. We will see an introduction to test-driven development or TDD. Finally, we will learn how to create a test widget for a Flutter widget. In order to carry out the points that I have mentioned, we will use the following tools. We will use the Flutter test package that is included by default when you create an application. To create the mocks, we will use mocktail. This tutorial is designed for people who have minimal knowledge of Dart and Flutter, but you don't need to have previous knowledge of testing, although if you do, this tutorial will help you become more familiar with them. Today I will show you my own testing design and creation paradigm. This way of testing applications has served me for years to be able to secure my code. Before I get started though, let me give you a very quick overview of what tests are, what they're used for, and why it's important to write them for your applications. Software testing exists because we must ensure that our end product will be flawless, efficient, and as reliable as possible. Basically, we want to be able to easily identify bugs or potential problems before our project reaches the end user. All of the testing techniques that we have today strives to create high-quality products, which in turn translates to a better user experience, which tend to lead to more sales and higher customer retention. Also, it is more cost-effective to fix bugs before they have reached the production environment. But there are also other interesting benefits. Testing will force you to write your code in a modular way, defining clear dependencies and responsibilities, which will in turn make your code cleaner, easy to maintain and easy to expand. Also, it makes refactors a lot easier, since the test will tell you if the previous functionality still exists or if it has been altered in some way. There are different types of tests, among which unit tests are the most basic. The unit test is the basis of any testing strategy, since a unit test tries to test a minimal and isolated unit of our project. In this tutorial, we will see how to create a unit tests file that will check the functionality and behavior of a class. Later, we will see how to create a widget test, which is essentially the same as a unit test, but specific to a Flutter widget. It is important to mention that unit tests are executed on your local machine, without launching your application, which makes them fast and efficient. There are other types of tests that do depend on having to instrument your application, but in this tutorial we will not go into that topic. We are going to start by creating a unit test. For this, we first need a project to work on. In this case, I'm going to clone the project I did in a previous video about clean architecture in Flutter. In that video, I explained how to create clean and functional code using an application that gets a list of movies. You have the link to this project in the video description in case you want to follow me in this tutorial. Once you have cloned the project, go to the branch called No Tests. I have prepared this branch by removing all existing tests so that we can create them from scratch. If you want to see the final result of what we're going to do here today, you can always go to the master branch. Now open the project with your preferred IDE. In my case, I'm going to use Android Studio. The first thing to check is that Flutter test is defined as a development dependency. As I said at the beginning of the video, this dependency is added automatically when you create a new Flutter project. I'm going to run flutter pubget to make sure I have all the dependencies installed. Now navigate to Data, Repository and open Preferences repository. We will use this class to create unit tests. The objective of this class is to act as a bridge between the preferences data source, which is who interacts with the native platform to obtain and save preferences, and the rest of the application. First, we create a test directory, and inside it, we replicate the same structure that we have in the app so that everything is ordered. Now create a file preferences repository test.dart, which is where the unit test will be. We start by creating the main method. Every Dart application must start in the main method, and tests are no exception. Now we begin to define a group called Preferences Repository. Groups are used to group components within tests. The reason why I have added a dash at the end is to improve the visualization of the execution of the test when they are executed from the console. The first thing we're going to need is an instance of the class under test, so I define it as a late variable. Note that in this case it is late but it is not final. The reason is that we are interested in recreating the class from zero in each independent test. So we will be able to execute the test from scratch, isolating any side effect it may have had any other calls to this class before. If you look at the Preferences repository class, we see in its constructor that it needs a Preferences class. And this is where I'm going to introduce you to one of the most common techniques when writing tests, mocking or stabbing. This technique consists of creating a dummy object that we will be able to manipulate at will. The objective is simple. To be able to test your application, you need to isolate it from the rest of the components. Imagine that your test fails, and it's not because your class under test fails, but because one of its dependencies is failing. To avoid this class, the classes under tests are provided with mocks or stabs, which are nothing more than masked objects of the original type that the class expects. But their behavior is defined exclusively by us in order to carry out our test. If this concept is still not clear to you, don't worry. Keep watching this tutorial because I think that when I program the behavior of these mocks, you will see what I mean. In any case, we first have to define these mocks. For this, we're going to install mocktail as a development dependency. This package will allow us to create these mocks easily and quickly. Create a file mocks.dart and define a preferences mock named preferences mock as follows. A note before we continue. The precise definition of mock and stab may not be the same depending on who you ask. What interests me is to inject into the class under test a dummy object that does what I tell it to do. So, in the rest of this tutorial, I'm going to call these kinds of objects mocks. Now import mocks.dart into the test class and define a variable of type preferences. Since our mock implements preferences, we can define this variable of type preferences but then instantiate it as preferences mock. Now we open the setup block. The purpose of this block is to prepare the components for the execution of each test. It is important that you understand that setup will be called before each of the tests. We initialize the preferences repository and pass it the mock we just created. Now we can start writing the tests. First of all, we're going to test the first method called setThemeMode. To do this, the first thing I'm going to do is define a new group with the following definition. I use the when given should structure, in which when indicates when it happens, given under what parameters, and should what it should happen. Don't worry if you don't quite understand it. Follow me and I promise it will make sense when you've seen the whole loop. Inside this group, we will write all the tests related to the call of the setThemeMode method. Now we have to define with what types of parameters this method can be called. In this case, with a ThemeMode object, which in turn has three values: system, light, and dark. For each case, I'm going to create a new group using the given terminology in which I specify what type of parameter the method is going to be called with. Now, we only have to write the tests that are going to verify that the class does what it has to do. For this, we open with a test type block in which we define what is required to happen using the should nomenclature. We are going to execute the function under test with the parameter that it requires according to the group in which it is. First, we test what will happen if we send it a theme mode with the system option. We have to import the material package to use this class. When setThemeMode is called with the system option, what needs to happen is that the preferences repository calls the setThemeMode method of preferences with the numeric value of the system option. And how are we going to verify that this happens? Well, luckily, preferences is a mock that is under our control. And among other things, it can log the calls that are made to it. I'm going to define a variable called captured. And using the verify method, as you can see here, I'm going to check that setThemeMode is being called. In the captured variable, we will obtain a list of parameters with which said method has been called. So to carry out the test, all I have to do is call the expect method, passing the index 0 of capture as the first parameter, since we expect setThemeMode to have been called once, and compare it to what we expect, which is the numeric value of the theme mode option system. In other words, we can use expect to perform the ultimate validation test that will define whether our test passes or fails. I'm going to run the test by clicking on the play icon next to it. Another way to run it is from the terminal using the flutter test command. When executing it, we observe that there is an error. Well, this has to do with the way mocktail works. This package allows us to easily define mocks, but forces us to define what happens when each method is called. In this case, we have called the setThemeMode method of preferences repository, which in turn calls the method with the same name of preferences. Since we are calling a method of a mock and we haven't told mocktail what should happen when that method is called, the test fails. Let's tell mocktail that when any test tries to execute the setThemeMode method of the mock preferences, it should return an empty future. We can do this using the when method as you see on the screen. Now we execute and see that the test passes correctly. Alright, can we move on to the next test now? No. You should always try to make your test fail. If you do that, you may find that your tests always passes, even if you provide a wrong argument. So let's expect a value other than system. We execute it and see that it fails. We do the same with the dark option. It also fails. Well, that means that our test is not going to give false positives. Now we can create the test for when theme mode is light and for when it's dark. We simply modify the relevant values and run all the tests to check that they are correct. Well, now you have seen how to create a unit test. Before continuing with the video, I'm going to ask you to click the like button if this tutorial is useful for you. Subscribe if you haven't and leave me a comment giving me feedback on how you think I can improve these tutorials. These types of actions help me a lot to grow this humble development channel. Thank you very much for your support. And now let's continue with the tutorial. Now that you know how to write a unit test once the code under test has been created, we're going to learn how to do it the other way around. We're going to create the test and then the code under test. And here you will be wondering, but what sense does that have? Well, this methodology is called test-driven development, or TDD, and it has the following benefits. When you apply TDD, you make sure that all your code will always be covered by tests, since you will always write them before writing the code itself, thus improving the final stability of the product. It is very safe to apply refactors. Once the test is done, you can write your code and change it again and again with the security that there will be a unit test that will support you and tell you if the new refactor still meets the requirements. Improved design. Since you always write the test first, this will force you from the very beginning to make your code modular and its dependencies well orchestrated. You stick to the requirements. Your code will meet the given requirements, no more and no less, since the goal of writing it is to make the test pass. And these tests are designed based on the requirements given for that task. This means that you will create the minimum increment required, which is essential in any agile environment. These are just some of the benefits that TDD brings. As for whether you should implement it or not, it's up to you. I personally always apply it, although there are programmers who prefer not to. In any case, my mission here is simply to give you a first contact with this methodology, so here we go. We are going to write the test of the getThemeMode method applying TDD. For this, I'm going to comment it and we are going to pretend that it does not exist. The requirements for this functionality will be being able to get the theme mode saved in the preferences. So I create a new group that is going to test a method that will be called getThemeMode. In our case, the requirements tell us that if the saved value corresponds to light, the return value should be thememode.light, but any other value should return thememode.dark. So I'm going to create two groups, one for each case. I begin to create the test of the first group. When the numerical value of theme mode corresponds to light, it should return the value thememode.light. As before, we have to make our mock that when we call its getThemeMode method, it returns the numerical value that corresponds to light. We do this using the when function as follows. Now we execute the function and check the result again with expect. I'm going to run the test and it's obviously going to fail. To begin with, because the getThemeMode method we want to test isn't even defined. This will be the first step to do. The second step is to create the signature of the method and make it return a dummy value. We run the test again and this time it should compile but it should fail, since it is not complying with what the test says. Our next task consists of refactoring this code to ensure that it complies with what the test is defining. Take a look at what I've done. I've written the bare minimum code necessary to make the test I just wrote pass correctly. However, I'm not considering the case that the numeric value returned by preferences is anything other than light. In other words, this test that I just wrote, it will pass correctly but not the next one. And this is the fundamental aspect of TDD, sticking very strictly to the tests, in order to achieve the minimum essential code that meets the requirements defined by the product. This prevents the existence of extra code that will not add value to the product. Now I write the following test, changing the appropriate values, and repeat the same process. First, I run the test, which fails because the code doesn't meet the requirements, and then I refactor the code to make it meet the requirements. And here is the short introduction to TDD. As you can see, it's another completely valid way of writing tests that has its advantages and disadvantages. If you are interested in me creating more material focused on this topic, do not hesitate to suggest it to me in the comments. But now we are going to the last part of this tutorial. We are going to create the equivalent of unit test but for Flutter widgets. The purpose of a widget test is to test that a Flutter widget behaves correctly. This kind of tests cannot be considered pure unit tests as such because they have to be executed in a very particular way, adapting to the widget framework provided by Flutter. We go to the presentation folder, list, and open moviepreview.dart. This widget represents each of the entries that are seen in the list. I'm going to execute it so that you can see it again. As you can see, each of these widgets contains an image, a title, and a description that is the release date of the movie. Also, when clicked, we go to the detail of the movie. We are going to check all these features in our widget test. To do this, I replicate the same directory tree in the test folder and create the file moviepreviewtest.dart. As before, I start by defining the main method and a group called moviePreview. In order to be able to test this widget correctly, we have to take into account that it can receive a movie type object that contains an image, but it can also not contain it. So I'm going to create two objects, one that contains it and one that doesn't. These objects will serve as input parameters later to check each of the cases. Now I'm going to create the following method. The reason I create this is because our widget depends on an ancestor of type material to render correctly. So this method takes care of encapsulating the widget under test with a material app. Now I can create a group that refers to what has to happen when the widget is rendered, and I specify the two commented cases, with and without image. When we create a test widget, we must use the test widgets method instead of test. This method also gives us an object of type widget tester, which is the way in which we are going to be able to instrument the events on the widget. You will see now what I mean. Let's see what has to happen if the incoming movie object has an image. This container is the top parent that has to be shown. For this, what we must do is look to find this widget within the widget under test. We can do this by means of a key. We define a key called ImageKey and pass it to Movie Preview. As you can see, this key will then be placed in the widget we want to refer to. We call the pump widget method, which is what will simulate rendering our widget, and pass it the movie object. Note that I am passing this object without an image. I do this to make it fail. Remember that it is just as important to check that the test passes as that it fails. In order to be able to find our image, we use the find.byKey method that will be in charge of telling us if it has found a widget with the key that we have told it. We end up making an expect in the following way, forcing a widget to exist with the key that we have defined. Otherwise, the test will fail. We run the test and see that it fails. It is normal since we have passed a movie without an image. We change this parameter so that it does have an image and we verify that the test passes correctly. Next, I am going to execute the same operation, but in the case that movie does not contain an image. Now we are going to check that both the title and the release date are being displayed correctly. To do this, I create a new test that will first check the title. This time we will use find.text to find a specific text within the widget tree of the widget under test. As always, I will first cause it to fail by indicating that I hope it doesn't find anything. I run to see that it actually fails, then I correct it and run again to see that it works correctly. Now I'm going to do exactly the same thing, but this time looking for the release date of the movie. To finish, we're going to verify that when I click on the widget, it directs me to the movie details screen. To do this, I create a new group that will cover the case of clicking on the widget. The first thing we have to do is simulate a click. For this, I use the find.byType method and look for a gesture detector type widget and tap on it. How can we check that there has been a navigation event? Well, there are several ways to do it. But in this case, what we're going to do is try to find a widget of a specific type. In this case, a movie detail screen type widget, since this is the new screen that has to be opened, using find.byType. Let's run the test and see what happens. We see that it fails. It says that it has no found said widget. But this does not make sense. In this case, everything we have defined is intended for the test to pass. What could be happening? The answer to this question is the timings. Unlike when you test a normal class, Flutter widgets contain animations. These take time. If you ask the test framework for a check, it will do it immediately without waiting for the animations to finish. In this case, tapping on Movie Preview opens a new screen. This includes an animation, so we have to make the test stop and wait for any animation to finish. We can do it using pump and settle as follows. Now I run again and see that it works correctly. I'm going to make it fail to check that it's okay, and I put it right again to make it pass correctly. This is the end of this tutorial on testing in Flutter. We have the links to this project in the video description. If you have questions, please ask me in the comments of this video. I will do my best to answer them to the best of my ability. I hope this video has been useful to you and you have learned something. If that is the case, please leave me a like if you haven't already, and consider subscribing to this channel for more content of this type. I will also really appreciate it if you could give me your feedback on possible improvements in my way of teaching so that I can do better in the future. Thank you very much for watching the video until the end. I hope you have a nice rest of your day. Goodbye.